Back in chapter 1, what we were working on was basically fractions and positives and negatives. Now here's the good news. You're going to have your calculator available for all of the final. So all of the things that I made you do by hand on the first test, you can actually use your calculator to do on the final. Although on the review here for the final, I'm going to do them by hand just for us to review that. But you probably want to review on your calculator as well. So you could see on your final something as simple as take a fraction like 25 over 40 and reduce it. Well, we know both of these would reduce by 5. 25 divided by 5 is 5, and 40 divided by 5 is 8. On your calculator, if you just hit 25 ABC 40 and hit equals, it'll reduce it down to 5/8 for you. Okay, and then the thing I kept hammering on and hammering on and hammering on is that a multiply problem is a cancel problem, and an add problem is a common denominator problem. So when we consider this next problem, 2/3 divided by negative 2/5, we know if it's division that we're going to flip the second one and multiply. So that's the same thing as 2/3 times negative 5/2. And that's a cancel problem because it's a multiply problem. So the 2's will cancel. A positive times a negative is a negative. 1 times 5 is 5. 3 times 1 is 3. How about negative 5/3? Or if you went 2ABC3 divided by negative 2ABC5, your calculator will either tell you negative 5/3 or negative 1 2/3. It keeps doing that. Where we have to apply the order of operations. So that's something that has been a recurring theme throughout the class. Please excuse my dear Aunt Sally. Okay, so if I gave you a problem like this, 5 times the quantity, 3 plus 2 cubed, divided by 5, then we know we got to work the parentheses first, and inside the parentheses I have addition and exponent. And we know we got to do exponent before addition. Hey class, what's 2 cubed? And don't say 6.
8.
It's 8. That's right. And as a general rule on your factoring test and on this test, remember I keep saying this, whatever speed you normally work, slow down 1 step and you'll save yourself a lot of mistakes. That's certainly true on order of operations problems. So let's kind of keep the pace slow here. We're still inside the parentheses. So next thing we're going to do is 3 plus 8. We're not going to try to do anything besides that. So I got 5 times 11 divided by 5. The parentheses are finally done. There are no exponents. They're done. And then remember, we're going to multiply and divide from left to right. So the first thing I need to do is take 5 times 11 and get 55. And then take 55 and divide it by 5 and end up right back at 11. And there's no add or subtract left. So we're going to have some order of operations problems. Okay. Near the end of chapter 1, we did some problems where the directions would either say simplify, which means combine the like terms, so the directions might also say combine the like terms on an expression like this. 6 times the quantity 3x minus 2 plus 4 times the quantity 2x plus 6. I'll tell you what, you guys go ahead and try that problem. I'll give you a minute or two to work out in front of me on it, and then we'll work it together. So this is really something that we've done so many times on lots of problems. Even since we did this section, we can do a lot of combining like terms and all kinds of different problems. We know we have to clear the parentheses before we combine the like terms. So 6 times 3x is 18x. 6 times minus 2 is minus 12. Distribute the 4. 4 times 2x is 8x. 4 times 6 is 24. And now that the parentheses are cleared, plus 18x and plus 8x is 26x. Done with those. Negative 12 and plus 24 is positive 12. So hopefully you got 26x plus 12. Okay, the last topic I want to review with you today from chapter 1 deals with sets of numbers. Remember we had those problems where I would give you some numbers and I'd say, hey, out of these numbers, which ones are rational or irrational or integers or whole numbers or natural numbers? So I want to review all those types of numbers. So I'm going to start kind of down here at the bottom. Actually, that's not what I want to do. I want to do this. And I want to talk about the natural numbers first. Does anybody remember what the natural numbers are? Yep, they're counting numbers. Like 1, 2, 3, 4, yada, yada, yada. No fractions, no decimals, no negatives, no zero with natural numbers. Just your counting numbers. Okay, now all natural numbers are also whole numbers. Somebody not named Aaron, tell me what we get with whole numbers that we didn't have in natural numbers.
0.
You get 0, good. 0, 1, 2, 3, 4. No fractions, no decimals, no negatives. Now, all whole numbers are also integers. Do you remember what we pick up with integers?
Negatives.
You get negatives, but you still don't get any fractions or decimals. So the pattern goes like this: negative 3, negative 2, negative 1, 0, 1, 2, 3. So if you got a fraction or a decimal number, it's not going to be natural, whole, or integer. It's none of those. Okay? Now, we get those when we get to the level where we have rational numbers and irrational numbers. So all natural numbers, whole numbers, and integers are rational numbers. None of them are irrational. If you want to tell the difference between a rational number and an irrational number, remember that an irrational number never ends. So it's a decimal that goes on forever and never repeats. In this class, the irrational numbers that we kept running into were square roots, but not square roots of perfect squares like 49 or 16, because those would be 7 or 4. It'd be like square root of 10 or square root of 5 or square roots of numbers that are not square numbers. Those are irrational. Everything else in here was pretty much rational. And then when you put those two sets together, you have the set of real numbers. And about the only thing in this class that we had that wasn't a real number would be something that's undefined, like 8 over 0. 0 in the denominator. That's not a real number. Everything else we had was a real number. When you get to intermediate algebra, you'll have another type of number that's not real, but you're not there yet. Okay, now that we've talked through that again, let's do the kind of problem like you would see on a test relative to this. And, okay, I think I found a good one here. Let's say your set of numbers included the following: negative 5.3, negative 5, a little bit hard to see, a second here, negative the square root of 3, negative 1, negative 1/9, 0, 0.1 with the bar over the 1, so it's repeating, square root of 5, 3, 5.9, and 7. Okay, so is the class at Olin or the class at Anna or the class at Metro going to volunteer to go first? Who's going first here?
What are we doing first?
I haven't told you what you're doing.
Oh, I'm sorry.
I'm just waiting for a volunteer. Okay, I see Tristan's hand up. We're going with Metro. Okay, so out of that set of numbers there, can you gentlemen give me all of the natural numbers?
Hey, zoom in.
Christian and Tristan, what are the natural numbers that are listed in this set?
You zoom in just a little bit.
Mm-hmm. Does that do it for you?
Yep. 0. Oh wait, no. 3. There's 3. Is that 7 on the end?
It is 7 on the end. Is that it?
Is that a 5.9?
It is 5.9, yes, sir.
Then
So do you want 5.9 or not?
no, that's it.
You're correct. Nicely done. The natural numbers in that set are 3 and 7. Anna or main campus? Who's volunteering next?
You can go.
Okay, main campus volunteered. Out of that set of numbers, I would like for you to tell me all of the whole numbers.
We got 0, of course.
You got 0, of course.
3 and 7, that's it.
Okay, you are correct as well. Nicely done. By the way, I'm kind of proud right now. Good job. Okay, that means Robert and Emily, we're gonna play the game a little bit different way with you guys. We're gonna go through and list all the integers, but let's go through number by number and you tell me yes or no. So, negative 5.3.
No.
Why? You're right. Negative 5.
Yes.
Okay. Negative the square root of 3.
No.
Why?
It's irrational.
You're right. Negative 1.
Yes.
Negative 1/9. Why not? Good. 0. That's supposed to be a 0. It looks about like a 6. There. Okay. 0.1 repeating. Why not? There's a decimal. Square root of 5.
No.
Why not?
Irrational.
Okay. 3.
Yes.
5.9. Why not? Okay, how about 7?
Yes.
Man, this class is on fire. You answered perfectly. Nicely done. Okay, let's go next with the set of rational numbers. And really, if we're going to do that, it might be easier to think about the numbers that are irrational. Okay, so Robert named off 2 irrational numbers to the class. Which 2 did he name off?
Square root.
Both of the square roots, you're right. So negative the square root of 3 and the square root of 5. So everything else is rational. Negative 5.3, negative 5, negative 1, negative 1/9, 0, 0.1 repeating. What else? 3, 5.9, I know I'm squeezing that in there, and 7 are all rational.